SysML v2 Deep Dive Lesson 3. Goodbye block, hello definition. The usage paradigm. In SysML v1, blocks were the dominant modeling construct. While blocks were primarily intended to represent types, in practice, even small configuration or variant differences often led to the creation of new blocks or extended block hierarchies. As a result, teams frequently drowned in a sea of blocks, leading to the dreaded block explosion in the project browser. SysML v2 generalizes this pattern. While v1 distinguishes blocks or types from parts or properties, v2 elevates definition and usage to root-level concepts applicable to everything, such as parts, actions, requirements, ports, etc. In practice, this means you define what a component is once, and then describe how it appears, connects, and varies only through its usage inside a system. This approach is commonly referred to as a usage-focused modeling paradigm. To understand this, we first have to realize that in SysML v2, we explicitly distinguish between what something is and how it is used. Part def, or definition. This is the blueprint, or type. It describes structure, interfaces, and invariant constraints. Part, or usage. This represents a role or a feature. It describes how a definition is used within a specific containing context. Let's look at this concept in action with a simple SysML v2 example. First, we define an engine. Part def engine. This line defines what an engine is. It is the reusable blueprint or type. At this point, the engine is not placed anywhere and is not part of any system. Next, we define a vehicle. Inside the vehicle definition, we introduce part myEngine: engine. This line does not define a new engine. Instead, it defines a usage of the engine inside the vehicle. That means myEngine is not a definition. Rather, it is a feature of vehicle that is typed by the engine definition. The key idea is that the engine definition is reused, while the system-specific structure is expressed entirely through usage. Now a quick technical note for our language experts. In SysML v2, features are technically types that classify the relationship between the containing type and the instances of the feature type. In this example, myEngine formally defines the relationship between vehicle and the engine it uses. Also, by default, a part usage like myEngine has a multiplicity of 1. This means every vehicle must have exactly one engine unless you explicitly allow otherwise. Now let's connect this back to the block explosion problem. In SysML v1, breaking a system into smaller parts often required moving from a block to a part and then to another block, even when those blocks were not intended for reuse. This made decomposition indirect and led to many one-off blocks cluttering the model. In SysML v2, the usage-focused modeling paradigm allows for a direct parts tree. You can build structure directly by nesting part usages, introducing new definitions only when reuse is actually intended. This keeps the definition library clean and pushes system-specific complexity into the usage hierarchy. At this point, you might be wondering, if definitions are reused, how do we handle variation? What if the vehicle from our example is now a sports car and needs different values or constraints? This is where SysML v2 introduces the idea of configuration in context. Because definition and usage are separated, variation is handled at the usage level, without changing the original definition. Let's look at this simple example. Here, vehicle defines an attribute called max speed. This is part of the vehicle blueprint. Now, instead of creating a new vehicle definition for a sports car, we define a usage called sports car. The greater than symbol means redefines. It tells SysML that we are taking an attribute from the vehicle definition and constraining it more specifically in this context. In this case, we are not changing what a vehicle is. We are simply saying that this particular usage of vehicle, the sports car, has a stricter maximum speed. The original vehicle definition remains unchanged and reusable, while the variation is handled locally at the usage level. One last important idea before we wrap up. This definition and usage pattern isn't limited to physical parts. SysML v2 applies the same structure consistently across the language. Once you understand how part def and part work, you already understand how requirements, actions, and ports are modeled. For example, a requirement def defines the rule, while a requirement represents the assertion or application of that rule to a specific system context. The same definition versus usage pattern applies to actions and ports as well. This consistency is one of the biggest design improvements in SysML v2. To sum up, here's a quick cheat sheet showing how SysML v2 concepts map to their familiar SysML v1 counterparts. In SysML v1, blocks were used to represent types. In SysML v2, that role is taken by part def. What used to be a part property is now a part, representing usage. Internal block diagrams are no longer separate artifacts. Internal structure is expressed directly inside definitions. And where v1 used instance specifications, v2 represents concrete occurrences as individual part usages. Next lesson, we explore regularity. We will see how requirements in v2 break down exactly like parts, finally unifying the model structure.